Namaste and a very good morning to all of you. My name is Mithun, and in today's video, I'll be talking about CART model or classification and regression tree model. We will be looking at the benefits of building a Namaste and a very good morning to all of you. My name is Mithun. In today's video, I will be demonstrating how you can import a CSV file into RStudio without writing any code. This is especially beneficial to those people who do not like programming or who may not have a programming background. As you can see here, this is the CSV file. It is called as the iris file. This is a very popular data set. It has 6 columns. The first column is ID. And we have flower characteristics like sepal length, sepal width, petal length, petal width. And the next column is species. There are 3 different species of flower, namely Setosa, versicolor, and virginica. What is the sample size in this data set? If I scroll to the last row, you can see here there are 150 rows of different flowers. What I want to do with this data set is import this into RStudio. To import a file into RStudio, you need to firstly keep in mind what is the path of the source file so that you can navigate it later. Here, I have saved this file in desktop. I've created a folder called as statistics. Within this folder statistics, there is a subfolder called as R sample files. And I will be importing the iris file from this particular location. To import the CSV file, let me first click on RStudio. As you can see here, this is the main screen of RStudio. The first window to the left-hand side top corner is what is called as the console window. In fact, my apologies, it is called as the script window. The second window is called as the console window. The third window that you see here to the right-hand side top corner is what is called as the workspace and the history window. The fourth window that you see to the right-hand side bottom corner is what is called as the files and the plots window. What you need to do is in the third window, click on environment. You see an option which is called as import. This is the option that will help me import a CSV file. The moment I click on this, R displays the different options. You can import a CSV file, or you can import an Excel file. You can import a SPSS file or from Stata or from SAS. Any of these options can be used to import from the appropriate source file. Now, since the source file in my case is a text file, I'll choose the very first option, which is called as from text. Let me click on this option. A new window pops up, which allows me to specify the location of the file. If the source file is in C drive, click on C drive. If the source file is in D, please click on D drive. Since in this case, my source file is in desktop, I'll go to desktop. Within desktop, I have created a folder called as statistics. Let me double click on statistics. There's a subfolder which is called as R sample files. Let me click on R sample files. I'll have to locate the file iris. So this is the file which I want to import. It is called as iris. Let me choose the option open. Here you can see what R does is it gives you a preview of the source file. You can make sure that all the variables are correctly appearing. ID, sepal length, sepal width, all of these variables have been correctly identified as the variable names. At the bottom, you can see here the data frame structure. So this is how it will appear in RStudio. You also have certain other options here like row names, separator, and decimals. If you want, you can specify the separator or the delimiter. If you click on the drop-down menu here, you have 4 different options: white space, comma, semicolon, or tab. Depending upon what is the delimiter in the source file, you can choose an appropriate option. Since the source file is a CSV file, I'll choose the option comma separated values. Once you've made sure that you've chosen the appropriate delimiter, you can scroll down and to the bottom right-hand side corner, you can see an option which is called as import. I'll click on the option import, and you can see here, RStudio has successfully imported the files. RStudio displays a message saying, showing 1 to 5 of 150 entries with 6 total columns. So this is how, without writing one single line of code, we can import a CSV file into RStudio. If you're interested in knowing what is the code that is utilized at the backend, you can see here in the console window, RStudio displays the code that it has used to import the file. You can see here, we have run read.csv function. We have open parentheses, and within parentheses, we have again put double quotes. We have specified the location of the file, and we have executed the code. If you want, you can copy and utilize this for further activities which involve importing a file. With this, I've come to the end of today's presentation. I request you to subscribe to my channel and hit the like button. Thank you very much for watching today's video. Have a great day. Whether you want to classify or you want to predict, you can use a classification and a regression tree model. It builds the tree based on what is called as the Gini's measure. You have multiple tabs here. I can choose the option output. I will ignore tree statistics and plots. I will click on the option independent variable importance to the model. Let me show you in the background, you have many variables here. You have around 8 different variables. I can't make a decision with all these variables. I want to identify the key drivers of customer spend. What are the 3 most important variables which drive profitability? So a simple visual summary would help me, and therefore I'm clicking on the option independent variable importance to the model. You can also choose under the node performance what is called as mean. Let me click on continue. I think this is good enough for us to go ahead and build a cart model. With this, let me click on OK. This is the model summary table. It just gives me a high-level perspective about what is the dependent variable, what is the algorithm that I'm using, which is cart. The dependent variable is amount of money spent. All the independent variables that I have supplied would be used. The maximum tree depth is 5. It gives me additional information as well. Now, I want to understand which are the key drivers of customer spend. So let me go straight to independent variables list. I'm not able to locate the independent variables list. Yes, this is the one. This is the chart which I was looking at. Independent variable importance. The longer the bar, higher the importance. Shorter the bar, lesser is its importance. From this, it is quite obvious that the most important variable which drives customer spend is who is he shopping for. Very, very important. Who is a customer shopping for? That is the most important variable as far as customer spend behavior is concerned. The second most important variable is gender, and the third most important variable is shopping style. So the 3 most important factors which drive profitability would be who are you spending for, what is your gender, and what is the shopping style. Usage of coupons is also important, but it is not as important as the top 3 variables. There are other variables like health food store, store organization, and vegetarian, which are not that important. To assess the overall quality of the model, you can look at what is called as the risk statistic. Lower the risk, higher the quality of the model. Higher the risk value, lower the quality of the model. With this, let me go to what is called as the tree diagram. Let me double click on this. And for better visibility, what I'll do is I'll increase the percentage from 100 to 200%. This helps me visualize the decision tree a lot better. The first node is what is called as the parent node. This is what is called as the parent node. Here we are summarizing the information of amount of money spent. You can see here the mean value is 399 point something, which can be rounded off to $400. This is what we saw even during the descriptive statistics. An average customer spends around $400. I'm interested in identifying those segments where customers spend more than $400. It gives me additional statistics like what is the standard deviation, sample size percentage, and the predicted value as well. When I look down, you can see here, right below the parent node, there is a variable called as who is a customer shopping for, right? So this is identified to be the most critical variable in driving customer spend. There are two branches here. The first branch is self and family. If a customer is shopping for self and family, look at the average spend. The average spend is $504. Compare this with the earlier number that we got, $400. 504 is greater than $400, which means that this is the first important segment that I will be focusing on. If a customer is shopping for self and family, he is the most profitable person. It can, gender does not play a role here because you don't see the variable gender appearing as of now. So who is he shopping for? If you're shopping for self and family, the profitability, the average spend is $504. Let me look at the second branch here. If a person is shopping for himself or for his spouse, the average amount is $363, which is less than the baseline spend of $400. They are not big spenders, but I can't make a decision based on this note. So let me scroll down and look at the customer's gender. Here, a customer could be either a male or a female. If you are a male, if you're a male customer who is shopping for himself or for your spouse, the average spend is $393. For male customers, the next important variable becomes usage of coupons. Here again, you have two different branches. Either you don't use coupons or you use coupons from newspapers. What is the average spend? The average spend is $378.63, which is again less than the baseline spend. So what do I infer about this particular profile? If you are shopping for yourself or for your spouse and the gender is male and you do not use coupons or you use coupons from newspapers, you are a less profitable customer because the spend is merely $378, which is less than $400. What happens when you use coupons from mailings or you use coupons from mailings as well as newspapers? The average spend is $410, which is better than $400. And therefore, node 6 is also very, very important because this represents the profile of those customers who are big spenders. When I look at some of the other nodes like node 7 and node 8, look at the predicted value here. It is 303 and 356 respectively. Again, it represents customers who are small spenders. Node 6 is one node which is very, very interesting because it gives me the profile of those customers who are big spenders. Similarly, I'm interested in node 1 because both these nodes give me the profile of those customers who are big spenders. One more thing that you might have observed here is in the case of CHAID, when you're using a CHAID algorithm, the branches could be more than 2. In fact, you can get 3 or 4, and therefore interpretation sometimes becomes difficult. In the case of a classification and regression tree model, you get binary splits. You can see here there are only 2 divisions. If I scroll down again, there are 2 divisions. If I scroll further down, you can see again 2 divisions. And therefore, a classification and a regression tree is very, very useful and it is simple to understand. Let me close the decision tree output So this is how you can interpret a decision tree out. There is another useful chart which is called as the means chart. Let me look at the means chart. In the x-axis, you have the different percentile values. You have the 10th percentile, 20th percentile, and the 30th percentile. What you see here is quite interesting. In the y-axis, you have the average spend. When you look at the 20th percentile, till about the 20th percentile, the average spend is around $500. But beyond the 20th percentile, this line starts dropping, which means that beyond the 20th percentile, the average spend is not as high. It continuously drops. In the industry, we mainly look at a cutoff of 30th percentile value. So even if you look at the 30th percentile or the top 3 buckets, you will be able to see a high spend. This is how you can interpret the means chart. There's one more small table here, which is called as gain summary for nodes. Let us look at the node level information. You have 4, 6, 5, and 8. 4, 6, 5, 8, and 7. This is each node. What is the sample size in each node that is given? And within this, the percent of people present in each node is also highlighted, and the average spend is given to you. If you consider the baseline spend as $400, you can see here node 4 is profitable because the average spend is greater than 400. Node 6 is also profitable because the average spend here is greater than 400. But when you look at 5, 8, and 7, node number 5, node number 8, and 7, the average spend is less than $400. It is 378, 356, and 303 respectively, which is clearly less than $400. So if I have to specifically focus my attention, I will be focusing my attention on node 4 and node 6. So this is how you can interpret a decision tree model. You can look at the means chart, the risk estimate, the predictor importance as well. One additional thing which I would like to talk about here is how do you save the predictions in the data set? Remember, we did not choose to create additional columns. If you want to create additional columns in the data set, how do you do that? You can go to dialog recall, choose the option decision tree. Here you see a tab which is called as save tab. Let me click on the option save. It is asking me to save variables. I can choose to save the terminal node number as well as the predicted amount, and then click on continue and say okay. The cart model will be run once again. But what is interesting here is when I look at the data set and scroll to the extreme right side, this is the original amount of money spent. You can see here the cart model has generated 2 additional columns. You can see here the first customer belongs to node number 6. The predicted amount spent is $409. So this is the actual amount of money spent. This is the predicted amount of money spent. The difference between the actual and the predicted value will give me the error. Lower the error, better the quality of the model. Higher the error, lower the quality of the model. When I glance through some of the initial cases, I can say that the errors are not very high. Yes, in the case of second customer, the actual amount is 383. The predicted value is 409. Look at the third customer, 577 is his actual spend. The model is predicting to be 504. There is some level of gap here. For the fourth customer, it is 436 and the predicted amount is 409. This is the node ID. Now, if you can recall the decision tree output, let me scroll up. What did we say? Node number 1 is very, very important because the average spend is 504. Similarly, node number 6 also is very, very important because here again, you can capture customers who have a high degree of spend. So what I'll do now is go back to the data set, right click on node ID and simply say sort ascending. You can see here, this is the same variable, but here after sorting in ascending order, all the node ID corresponding to 1 will appear right at the top. So this is the most profitable segment, and the predicted value here is 504. If I scroll down, I can also look at node number 6, because node number 6 is also a profitable segment. Yes, this is also a profitable segment because this represents customers who are spending greater than the baseline amount of $400. So to summarize the benefits of a cart model, firstly, it is simple to understand, interpret, and visualize. It helps in variable screening and feature selection as well. It can handle mixed data type. It can handle both categorical as well as scale variables. Little effort for data preparation. It can be used to model non-linear relationships. Two additional points which I have not highlighted here are that it gives me binary splits, and the formula it uses to construct the tree is what is called as a Gini's measure. With this, I have come to the end of today's video. In case you have liked this video, I request you to subscribe to my channel and hit the like button. Thank you very much. Have a great day.